Assalamu alaikum, dear student. This is Wajid Ali Shah, and today we are going to explain the topic capacitor, given on page number 38. Capacitor is a circuit element which is used for storing electrical charge or electrical energy in itself. Construction of capacitor is two conducting plates of area A placed parallel at a distance t from each other. Working principle of the capacitor is electrostatic attraction. Electrostatic attraction means that one type of charge is produced on one plate of the capacitor, another type of charge is produced on another plate of the capacitor, and they electrostatically attract each other, and that is the main reason of staying the charges at the capacitor. Working of a capacitor, we can explain the working of capacitor by two concepts. One is charging of the capacitor, how we can charge a capacitor, another is discharging of capacitor, how we can discharge a capacitor. So the question is how we can charge a capacitor. So we can charge a capacitor by connecting it to the terminals of the battery or the power supply. And how we can discharge a capacitor. So we can discharge a capacitor by connecting it to the resistor. What is a resistor? Resistor is basically that circuit element which consumes electrical energy. Capacitor equation is Q is equal to CV, where Q is used for electrical charge, C is the constant which is used for capacitance of the capacitor, and V is the potential difference or the voltage applied to the capacitor for charging. So, depending upon the capacitance, there are so many types of the capacitor, shapes of the capacitor, values of the capacitor available in the market. Some are bigger and some are smaller, depending upon their usage. The unit of the capacitance is farad. After the name of the Michael Faraday, we can use bigger units like megafarad, gigafarad, and smaller units like nanofarad, microfarad, millifarad, according to their use, according to their purpose. Now, depending upon our own need, sometimes we basically combine two or more than two capacitors in parallel combination or series combination, or we can use both of them series cum parallel combination. So let us suppose, first of all, parallel combination of the capacitor. In parallel type of the combination of the capacitor, we connect all the capacitors like with each other, and then they are finally connected to the terminals of the battery like this. This is parallel combination of the capacitor. Let us, for example, this is C1 capacitor, C2, and this is C3. And this is power supply, the battery. So, in parallel combination of capacitors, we can write the equivalent capacitance of these three capacitors like C equivalent is equal to C1 plus C2 plus C3. Equivalent capacitance is that capacitance which is basically the total sum, the resultant combined equivalent effect of all the capacitances when they are connected in a single circuit and they are active. Again, series combination. Series combination of capacitors is that in which we connect one capacitor after another, and they are connected to the battery like this. This is, for example, C1, this is C2, this is C3. The equivalent capacitance of this type of combination is written as 1 over C equivalent is equal to 1 over C1 plus 1 over C2 plus 1 over C3. This is called series combination of capacitor. And the third type of combination which we can practically use is series parallel combination of the capacitance. In this type of combination, we can use both of them, series and parallel, both of them. For example, we have four capacitors like this, again, like this, and finally they are connected to the battery, the power supply, like this. This is battery power supply. This is C1, this is C2, this is C3 and C4. C3 and C4 are in parallel with each other. C1 and C2 are in series with each other. And this is a circuit which explains the whole concept of series cum parallel combination. So this is the main type of combination of the capacitors. Now we are going to explain the capacitance of a parallel plate capacitor. What is capacitance? For that reason, for that purpose, we are going to derive an equation for capacitance of the capacitor. And that equation is basically can be derived for the parallel plate capacitor. So, what is capacitance? Capacitance is basically the capacity or the capability of a capacitor to store electrical charge. Capability of a capacitor to store electrical charge or electrical energy. Different capacitors have different capacitance or different capability of storing electrical charge. For the derivation of the equation for capacitance, derivation for the capacitance equation is that, like previously we have discussed a concept of potential gradient where we can write it like this. This is equation 1, where E is used for electric field intensity, V is used for potential D, and D is the distance between the two plates of capacitor. This is equation number 1. Another equation which we can use is depending upon electric field intensity of a parallel plate capacitor. Like this, we have already derived this equation in previous videos, and we can write it like this is equation number 2. Now, in this equation number 2, we have already explained like sigma, charge density as charge per unit area. We can put this value of charge density into this equation number 2, and we can write it like this: total charge divided by A into epsilon naught. This is equation number 3. Now, comparing this equation number 1 and this equation number 3, we can say that equation 1 becomes equal to equation 3, and we can write that Q divided by A epsilon naught is equal to V divided by D. Again, as we know that V is equal to Q divided by C, taken from the capacitor equation. Now put the value of V from this capacitor equation into this equation number. This can be given equation number 4. So putting the value of V, we can write Q divided by A epsilon naught is equal to Q divided by C into D. D will come at its own place, and instead of V, we have put the value Q divided by C. Now, cancelling Q on both sides and rearranging the equation, we can write that C is equal to epsilon naught A divided by D. This is the equation derived for capacitance of a parallel plate capacitor. And it shows that capacitance is directly proportional to permittivity of the free medium. Capacitance is directly proportional to area of the plates, and capacitance is inversely proportional to the distance between the plates. This is the result and the concept of capacitance of a parallel plate capacitor. This relation shows that if we insert a medium between the plates of capacitor which is having more permittivity, so that capacitor will increase its own capability of storing charge. If we increase the unit area of the plates of the capacitor, so capacitance will again be increased. And if we decrease the distance between the two plates, so capacitance of the capacitor will automatically increase. And that's all about the topic of capacitor and capacitance. Thank you and Allah Hafiz.